This is the Trigonometric Ratios Using Right Triangles tutorial. There are 6 basic trig ratios of right triangles that you should be aware of. The ones on the left here, sine, cosine, and tangent, are the most common that you see, and you can use that acronym, SOHCAHTOA, to help you remember how to solve with these trig ratios. Remember, if you look at this acronym, SOH, S-O-H, stands for sine is equal to opposite over hypotenuse leg length, which is exactly what you see here, the opposite leg length over the hypotenuse length. In our triangle, if we took the sine of angle A here, we would simply divide the value of our lowercase a, so the side opposite that angle A, over the hypotenuse, so in this case C. You'll notice that cosine is adjacent over hypotenuse, so the leg adjacent to angle A, which is leg B here, divided by the hypotenuse C. Tangent is opposite over adjacent, so our opposite leg length of angle A, since we're taking the tangent of angle A, so the opposite leg is lowercase a here, and the adjacent leg is B here. Then you have cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and cotangent, which is the reciprocal of tangent. And those, you'll notice, are just the opposite of their respective trig ratios. So cosecant, if you just flip what sine's measurements were, so sine said opposite over hypotenuse, cosecant, its reciprocal, is just hypotenuse over opposite. So that's the easiest way to remember the ones on the right. So let's go ahead now and take a look at some examples using trig ratios of right triangles. Here's our first example. What I'd like you to do is determine the 5 remaining trigonometric ratios of triangle XYZ in decimal and fractional form, if angle Y is a right angle and the cosine of X is equal to 24 over 25. So remember, cosine of X is this guy here. And cosine of trig functions tells you to take the adjacent leg length over hypotenuse. So this is our adjacent over our hypotenuse. So we can plug those in now in relation to angle X. So our adjacent is 24, and our hypotenuse is 25. Now if you remember your Pythagorean triples, this is a 7, 24, 25. So this side over here, side YZ, has a length of 7 units. So we've got one of our trigonometric ratios. We want to solve for the missing 5. So I'll begin with sine. We're going to take the sine of angle X, and that's going to be equal to the opposite of X, which has a value of 7 because that's directly opposite angle X, over the hypotenuse, which is 25. So that 7 over 25 in decimal form is going to be 0.28. So you could have either the sine of X is equal to 7/25, or you could have the sine of X is equal to 0.28. We know cosine because that was provided for us. Now let's take a look at tangent. Tangent of angle X is equal to the opposite leg length of X, which is 7, over the adjacent leg length of X, which is 24. So we can write it as a decimal by just simply figuring out 7 divided by 24, which has a value of approximately 0.29. Next, let's do the cosecant of angle X. So we want the cosecant of angle X, and cosecant is here, hypotenuse divided by opposite. Remember, it's the opposite of sine. So our hypotenuse is 25, and the opposite side of angle X is 7. So 25 over 7 comes out to be roughly 3.57. Now we can take the secant of X. So secant of X is equal to the hypotenuse divided by the leg adjacent to X. So our hypotenuse is 25, and our adjacent leg is 24. And that as a decimal is 1.04. Lastly, let's take our cotangent of X. So cotangent, remember, is the opposite of tangent, the reciprocal, so that's just adjacent leg over opposite leg. The adjacent leg to X is 24, and the opposite leg to X is 7. 24 divided by 7 as a decimal here is 3.43. So those are the remaining trig ratios of triangle XYZ in decimal and fractional form. Now let's take a look at a word problem. Alright, so in this construction problem, it says that a roof is considered to be pitched if its angle from the horizontal is greater than 15 degrees. If the roof pictured below has a rise of 18 feet and a width of 50 feet, is it a pitched roof? So let's start by plugging in what we know. We know that the width, indicated here in green, has a length of 50 feet. And we also know that the height here has a length of 18 feet. So you'll notice we can now make two right triangles out of this image here. Now take a look at the angle from the horizontal that we're referring to. That's this angle right here on both triangles. Here's the horizontal down at the bottom, that beam directly across, and so the angle being made is when this leg right here, the hypotenuse, rises up, it creates an angle right there. So that's the angle that we're referring to here when we say the angle of the horizontal. So we want to know if that is greater than 15 degrees. If it is, then this is what you would consider to be a pitched roof. So if I just refer to that angle as angle X, I can use what we know of trigonometry and the other sides provided here to solve for that angle. Alright, so let's start with the horizontal. We know that the whole horizontal measurement is 50 feet. So this half of it on the left must have a length of 25 feet. By the way, that single tick mark there after the 5 is referring to feet. So we have a triangle that is 25 feet long on the adjacent side to angle X and 18 feet long on the opposite side. So I'm going to say that the tangent of angle X here is equal to the opposite side of angle X, which is 18 feet, over the adjacent side of angle X, which is 25 feet. So here's our trig ratio. The tangent of angle X is equal to 18 over 25, and we want to solve for X. So I'm going to take the inverse tangent of both sides. So we can just take the inverse tangent, so tangent -1 here, to both sides of the equation. When you do that, you have just X remaining on the left. On the right, you have it written as this, the inverse tangent of 18 over 25. And you can put that directly into your calculator. When you do that, you'll find that X has a measurement of roughly 35.75 degrees. So that's this angle right here, which means that this would be considered a pitched roof because that angle is greater than 15 degrees. So these are some of the ways that you can use trigonometric ratios to solve for the missing components of right triangles, whether that be the angle or the sides that are missing.